In example number 3, I stated that if I could find a value for x, that when I substituted it into my expression, that value would help me to find the first factor when factorizing a cubic expression. Now, in example 3, that was easy because I could see when x was 1, I was going to quite nicely get a 0 answer. But it's not always that simple. And if this is the case, we need to resort to a second theorem, the rational roots theorem. In essence, the theorem says if I take any factor of the constant term over a factor of the coefficient of the x cubed term, and I substitute those numbers into my expression, that should help me to get an answer. So let's see what these factors could be. So I could be substituting in plus numbers or minus numbers of the numbers that can go into 3, which are 1 and 3, over the numbers that can go into 2, and the numbers that can go into 2 are going to be the numbers of 1 or 2. So let's check and see what these numbers actually could be. I could try substituting 1 over 1, which is plus or minus 1. I could try and substituting 1 all over 2, which is plus or minus 1 all over 2. I could also try substituting plus or minus 3 over 1, and I could try substituting 3 all over 2. The nice thing about this method is it takes away all the other options that you might try. You might have tried substituting plus or minus 2, but that's not going to help you because I know for a fact that those would not have given you a 0 answer. So what we have to do now is through trial and error, we have to see which one of these options would have worked. So I want you to pause the video at this stage and try. If you substitute 1, are you going to get a 0 answer? Well, you can see quite clearly that that would not give you a 0 answer. Now go on and try minus 1. Try a half, minus a half, 3, minus 3, plus 1.5, or minus 1.5. But as soon as you get to an answer, you know that you have a value that can help you to get to your first factor. The number that I'm going to try is when x is going to be equal to minus a half. If I substitute minus a half into my expression, I'm going to get 2 times minus a half, all cubed, plus minus a half, all squared, minus 6 times minus a half, minus 3. Now, if you work that out on your calculator, you'll find very conveniently that we have got a 0 answer. In other words, that number, when x equals minus a half, is going to help me to get my first factor. But what would my first factor be equal to? What I want you to do is I want you to change that so that all the information is on the left-hand side equal to 0 on the right-hand side. If I do that first using an LCD, I'm going to get 2x is equal to minus 1, and so therefore 2x plus 1 is going to be equal to 0. Doing this, I have successfully found my first factor. So therefore, when I have factorized the original expression of 2x cubed plus x squared minus 6x minus 3, my first factor is going to be 2x plus 1. Now I need to find my second factor. Remember what I said to you in the last example, that if I take my first term and I times it by the first term of the next bracket, I must get the result for the first term of my original expression. As I already have 2x, I just have to multiply that by x squared. Then, if I take a look at the last term that I had, my last term was 1, and I have to times that by something so that my answer is going to be minus 3, the last term of my original expression. And if I times 1 by something to get minus 3, I have to times that by minus 3. As with the last example, the problem is finding the middle term, and so there must be something times by x to get to the middle term. In order to find this value of y, we're going to concentrate on the coefficient of the x term in the original expression. How would I get to this minus 6? Well, if I take the first term times by the last term and concentrate on the coefficient only, 2 times minus 3 is minus 6. If I take the second term of my linear factor and I times that by the middle term of my next factor, I must add y, and my answer must be equal to minus 6. Well, if my answer should be minus 6, and I take my 6 across, the y, in fact, is 0. In other words, if I rewrote this expression over here in terms of its two factors, I would have had x squared plus 0 times x, which means that I don't need to show that term, minus 3. As with the last example, I need to always take a look at the second factor, which is the quadratic factor, and see if I can factorize it further. This is a very nice difference of two squares, and so my difference of two square factor brackets are going to be x plus the root of 3 and x minus the root of 3.